Hey, Algebra 2. This is lesson 811. This is our first lesson in chapter 8. Chapter 8 is all about polynomial equations. We're going to learn how you can draw a graph based on just the equation and without using a graphing calculator. All right, so some of the polynomial equations we have learned before this have been the quadratic equation. So that's like y equals x squared. Looks like a parabola starting at 0, 0. And also we've learned about a cubic function, y equals x to the third power, which I think of kind of looks like a snake. All right, so there's two different types of forms that we have for polynomials, the standard form versus the factored form. Factored form has parentheses, has sets of factors, and those factors tell us where the x-intercepts are. So we're going to take a look at some of the different polynomial functions and notice different features of these. So I have already graphed these three example equations using Desmos. If you notice, they all have an x-intercept at 0, 0 and 2, 0. 0, 2 and 0, 2. This third one also has an x-intercept at 3. Okay, so each of these x-intercepts can be predicted from the function. So 0, 0 comes from the function where we look at x. All right. So x tells us that there is a point at 0, 0. X minus 2, that factor tells us that there is a point at 2, 0. There's an x-intercept there at 2. Okay, if you remember from quadratics, insiders lie. So those x-intercepts use that same number from the factor. It's just a different sign. So you see how in this third one, there is a third factor of x minus 3. So we see x minus 3 in the graph as an x-intercept at 3. All right, so then for predicting the equation of this graph at the right, we're going to use the x-intercepts that are shown on that graph. So 0, 2, and 3. Okay? So our equation, again, from these other equations, they all had an x in the very front that represented that 0 x-intercept. So this one has a 0 x-intercept, so it's going to have an x in the front. Our second factor is going to come from that 2. So it's going to be x minus 2 instead of plus 2. And we would have an x minus 3 from the x-intercept of 3. Okay, if you try to graph this, it's not going to look exactly the same as this graph above. It might look something more like that maybe. Okay, so we need to change something in our equation. Now if you notice over here in the middle equation at x minus 2, I call this, it bounces at 2. So kind of like a bouncy ball. Think of the x-axis as a floor. It bounces off the floor and goes back up. Okay, so the difference between all of the other functions and this middle one, none of the others have exponents, whereas this middle one does have an exponent. So that exponent 2 represents bouncing at 2. All right, so now if you graph this equation, it's going to match. Okay, so we're going to look at three different equations and practice graphing these based off of the equation given. So this is the first one. Which family of function does it belong to? This is going to be helpful in discovering the shape of the graph. So the family of functions that this belongs to is y equals x to the third power, also called a cubic function. So like I talked about in the very first slide, that function kind of looks like that, where it starts at negative, negative, kind of curves up and goes to positive, positive. So how do we know that it's a y equals x to the third power? Okay, so this number right here is what we call a degree. That tells us how many factors we have. You might be thinking to yourself, there's only 2 factors in there. Why are you saying that there are 3? Because this counts as 2. I could write this out as x minus 2 times x plus 5 twice. That's what a square means. You're multiplying it times itself. So there are 3 factors. It's just that one of the factors is the same thing. So since this one has 3 factors, that means that we have a degree of 3. Okay, if we had 4 factors, then our family of functions would be y equals x to the power of 4, which doesn't really have a fancy name, just a 4th degree polynomial. All right, so then I know that this equation is going to have an x-intercept at positive 2 because of this factor right here. X minus 2 means that we're going to have an x-intercept at the 2, but at the opposite sign. So as we notice, we already have it graphed right here. There's that x-intercept at 2. Okay? And then we also have x plus 5. So we're going to have an x-intercept at negative 5. But since there is an exponent of 2, it just bounces at 5, so that's why it doesn't go through right there. Okay, and then so reading from left to right, describe the graph before, after, and then after the second x-intercept. So before that first x-intercept, it is below the x-axis. It comes up and it touches the x-axis, but then it goes back down below. And then it swings back up, goes through 2, and then ends up in the positive direction. All right, so a 3rd degree polynomial always starts in the bottom, negative, negative, and ends up in the top, positive, positive, as long as there's a positive number in front of it. Okay, our second equation has 3 different factors, which means we have 3 different x-intercepts. None of them have an exponent of 2, so none of them are going to just bounce. So how many distinct factors? We already answered that. 3 different factors. So we're going to pretend like we don't see that graph over there. There would be 3 x-intercepts. And then we have that graph drawn. So again, I'm going to show you how we would just predict where the x-intercepts would be based on the factors. Since that's a factor of x minus 2, we have an x-intercept at positive 2. Since we have a factor at positive 2, there is a x-intercept at negative 2. And lastly, x minus 3, that is represented over here, x-intercept at positive 3. They all go through. And again, 1, 2, 3, a degree of 3 starts out in negative, negative, then goes positive, positive. All right, and that's how it's similar to that last graph. So similar to P1 of x because it's the same family. The constant factor of 2, so that number in the very front right here, does not have any effect on the x-intercepts. What it does affect is the stretch. So if you remember from quadratics, if we had y equals x or 2x squared, then it would be stretched narrow. If we had y equals like 1/2 x squared, then it would be wider. So that's what the number in front does in other polynomials as well. So the leading coefficient stretches the graph. That's another vocab word. Leading coefficient is that 2, the number in front. What if we changed 2 to negative 2? Well, if we changed that quadratic, the number in front, to negative, it would just flip down. So same thing with polynomials. If we changed the number in front to a negative, it would flip the other way. I'm just going to write that to represent negative. So this graph would look like this instead. So it'd start in the positive direction and end in the negative direction. All right, and then number 5, this is our third and last equation. The main difference here is that there's no parentheses. It is not in factored form. So this is what we call standard form. We can't really determine any x-intercepts from this. We would have to actually factor it out. What I notice, sorry, I can't talk and write at the same time apparently. So we would have to factor this out. And I notice that there's an x in each of the 3 terms, so I'm going to factor out an x. And then we'd be left with x3, because we just get rid of one of the x's, 21x, and then plus 20. All right, and we cannot factor that anymore because the exponent is 3 in the front, and we can factor a 2. We would just figure out what 2 numbers multiply to 20 and add to negative 21. But since that's a 3, we can't do anymore, at least with our knowledge right now. All right, so then since there's an x in the front, we know that there's going to be an x-intercept at 0, which there is. All right, and so I went ahead and I graphed this, and I'm going to write it into factored form. So this factor is at, or this x-intercept is at -5, so that means I'm going to rewrite the x in the front. We're going to have a factor of x plus 5. Remember, same number, opposite sign. Another factor could come from here. So that x-intercept is at 1. Since it's positive 1, the factor is going to be x minus 1. And another factor, x minus 4. All right. And then overall should be, it's a 4th degree polynomial, so we should have 4 factors. So 1, 2, 3, 4. So we're good. You can always put this in your graphing calculator and Desmos to check. All right, so which form of the equation is most useful? That would be factored form. And what information does it give? Gives us the x-intercepts. How does changing the exponent of one of the factors change the graph? So remember back when we had from that second slide, x minus 2 versus x minus 2 squared. So this one goes through, well, they both go through 2 or touch 2. This one actually goes through at that x-intercept, whereas this one just bounces. So the exponent changes the way the graph acts at that x-intercept.